So last day of learning about systems. This is your last process, and that's the elimination process. One thing I want to mention before we jump into this, you can use any of the three processes that I've taught you up to this point to solve for systems of linear equations. So what I mean by this is that if you're looking at two equations and you are trying to use one of the systems processes, if you already have a variable set equal to something, so y equals x equals a equals, etc., I would use the substitution process to find your answer. If you already have two equations that are set up in the y equals mx plus b form, I would use the graphing process. And now, if you already have two equations set up in the way I'm going to teach you today, I would use the elimination process. So these three ways you can solve for any of systems of equations. It is not required for you to have to choose one unless it is specified in the question that you are solving. So be free with your choice. So solving systems of linear equations is what we're learning today. There are 5 total steps for solving systems of linear equations by elimination. Step 1, multiply, if necessary, one or both equations by a constant, so at least one pair of like terms has the same or opposite coefficients. Step 2, add or subtract the equations to eliminate one of the variables. Step 3, solve the resulting equation. Step 4, substitute the value from step 3 into one of the original equations and solve the other variable. And then step 5, of course, check your answer to ensure you are correct. So let's go through an example here. So we're looking right here at these two equations, solve the system's linear equations by elimination. So you have 3x plus 2y equals 4 and 3x minus 2y equals negative 4. So let's look at step 1. Because the coefficients of the y term, so 2y and then negative 2y, are opposites, you do not need to multiply either equation by a constant, okay? You don't have to do step 1. We can jump right into step 2 because they're already opposites. And so we are going to go ahead and add our equations together because if we add, we are going to eliminate our y's, hence the elimination process. We're trying to eliminate a variable. So let's go through this. 3x plus 3x is 6x. Positive 2y plus negative 2y is 0, which is why it's gone. And 4 plus negative 4 is 0 as well. And so now we're at 6x equals 0, and we're one step closer of solving for one of our variables. Step 3, let's solve for x. So we're going to divide by 6 on both sides to get x isolated, and you will end up with 0. So we know that our x for these two equations will cross at the point of when x is 0. So now let's go to step 4 and solve for that y. So we're going to substitute 0 in for x for one of the original equations. You can choose the first equation or the second equation. It does not matter. And so let's go ahead and use equation 1, 3x plus 2y equals 4. Substitute out x for 0 because we just solved for x. 3 times 0 is going to give you 0, so that's gone. So now you're left with 2y equals 4. Divide by 2 on both sides, and y equals 2. And so now our two systems cross at the point of when x is 0 and y is 2. That is our answer. The solution to these systems is 0, 2. Step 5, let's check just to ensure we are correct. Let's go ahead and use equation 2 just to kind of switch it up. 3x minus 2y equals negative 4. Substitute out x for 0. Substitute out y for 2. And then solve. 3 times 0 is 0. Negative 2 times 2 is going to give you negative 4. So 0 minus 4 is just negative 4. And negative 4 does in fact equal negative 4. So we are correct with our answer. All right, let's go ahead and show you one more example. If I run out of time, just go ahead and start the activity. So solve the system's linear equations by elimination. We have negative 10x plus 3y equals 1 for our first equation and negative 5x minus 6y equals 23 for our second equation. Step 1, multiply equation 2. So again, we need to make one of our coefficients the same because they're not yet. So multiply equation 2 by negative 2 so that the coefficients of the x terms are opposites. You could have picked y to eliminate, but let's just work with x. So negative 2 times negative 5x is going to give you a positive 10x. Negative 2 times negative 6y will give you a positive 12y. And negative 2 times 23 will give you a negative 46. All right, and then you just do the exact same process of that last question, Joel, to find your x and y. Let me know if you have